Hello everybody, welcome to our presentation on a touchscreen electric bike throttle that we prototyped for Applied Science 459 class in the Engineering Physics program at UBC. My name is Robert Willems and my partner for this project was Colton Brummett. The sponsor of this project was Justin Lemire Elmore of Grin Technologies, an electric bike company located here in Vancouver. Currently, there are only mechanical throttles used on electric bikes, twist grip and thumb throttles, which both use the Hall effect to control the signal sent to the motor controller. There are a few downsides to these throttles, as they sometimes can be hard to reach and uncomfortable to hold while trying to control the bike. Justin's idea was to use a touchscreen interface for a throttle to allow different styles of input to best suit the user. It also allows for easy cruise control features and the possibility of combining the throttle with other devices such as the Cycle Analyst, also developed by Grin Technologies. A couple design specifications in order for this project to be a viable replacement for the current throttles were that it should run on less than 5 milliamps of current and cost no more than $30. The main parts of this project were designing a circuit and programming the interface, as a mount and case were supplied by Justin. We had a few options for touchscreens, but decided to go with a resistive touchscreen over the capacitive for a couple reasons. One of the main reasons was that often bikers wear gloves, which don't respond to capacitive touchscreens unless they are designed to.
For everyone who does not know how resistive touch technology works, there are two conductively coated plates with a small gap in between them. A voltage is then applied across one of the plates so that when a force is applied on the touchscreen, the two plates contact and it acts as a simple voltage divider, with the other plate being at the middle voltage. To read the position, you then measure the voltage of this plate, which varies linearly depending on the position of the touch. The printed circuit board was cut out using a PCB mill located in the UBC project lab. This shows the completed board with all the components mounted on it. The brains of the device is a surface mount PIC processor. It reads the input from the touchscreen to vary the PWM output. This output runs through an RC filter, a buffer, and then goes to the motor controller. There are also a couple of other inputs, for a brake line to set the output low when pressed, and a pedal sensor which will be used in future development. Here's a shot of our circuit and touchscreen mounted inside the case with various input and output connectors. Now for the interfaces. We programmed 3 different modes in which the user can control the output. The first one acts very similar to current throttles by varying the output linearly depending on the position. Also, when released, the output is set to 0. The second interface uses an algorithm to locate where your thumb is down and where your thumb is lifted, and then adds or subtracts the difference between these locations to the output. So swiping your thumb up will increase the speed, and swiping your thumb down will decrease the speed. The third interface adds or subtracts the difference between the original touch down and the current touch position, so that it behaves very similar to the second interface, except that it updates as you move your thumb, not when your thumb is lifted off. We leave you now with a quick shot of the throttle in action running the first interface. Thank you for taking the time to view our video presentation on our electric bike throttle.